Today's lesson is Investigation 9. Please make sure you have a copy of this so you can write down answers as we are talking. Alright, so today we're going to talk about graphing functions. A function is a rule that tells the relationship between numbers. We've done functions in the past in one of our past lessons, and so we're going to take it to the next step. We're going to do graphing of our functions. We can graph them on a coordinate plane, and we use an XY pair of numbers as coordinates of a point on the plane. So the first number is always X and Y is the second number. And sometimes they'll name it other letters, but it still is the same idea. So if we have a function table for Y equals 2X, this is what the graph looks like. You'll see that it goes through the origin, 0 and 0, and then they go to 1 and 2, 2 and 4, and 3 and 6. So, but those aren't the only numbers that can be on that table. We could put 1.5, 2.5, 3.5, 4 3/4. We could go on all the way up to 1,000,000 if we wanted to. So because of that, we draw a straight line through the points to cover all of our fractions and mixed numbers. And then depending on your problem, you may have a segment, a ray, or a line going through that. So it kind of depends on what problem they give you as to what how you're going to draw your arrows, or if it's just going to be a line segment. So this is a graph of the relationship between the side length, and the perimeter of a square. Notice that the x-axis and the y-axis are called S and P. So right here we have S for the x-axis and P for the y-axis, and it's always the left side is X and the right side is Y. And I remember it because X comes before Y in the alphabet, so X comes first. And so they've named it S and P, and that's okay. And it says the graph of this function is a ray. What are the coordinates of the end point of this ray? So a ray always has an end point. It doesn't go on forever. And you will notice that the end point of this ray is where I just drew the purple dot at 0 and 0. Okay, and so that is our origin. Now keep in mind that this is a graph about the relationship between the side lengths and the perimeter of a square. Can I have a -5 side length? No, I don't think I've ever heard of -5 inches. It doesn't work that way, does it? So because of that, that's why it stops at the origin and doesn't go on into our negative numbers. So that's why it's a ray and not a line. It says the graph of the function P equals 4s, perimeter equals our 4 times the sides, is a straight line and not curved. So again, look at that. You'll notice that this graph right here is a straight line. It is not a curved line. Below are 2 squares. The side lengths of the larger square are twice the side lengths of the smaller square, because 2 times 2 is 4. So we're going to find the perimeter of each of them. So on this one, all the side lengths are 2 centimeters, and 2 times 4 is 8 centimeters. On the other one, that's twice as long, we have 4 centimeters on each side, and 4 times 4 is 16 centimeters. And so I want you to think about that. We know that the bigger square is twice as big as the smaller square. What effect does that have on the perimeter? Good. I hope you noticed that the smaller square was 8 centimeters and the larger square was 16 centimeters for their perimeters. And 8 times 2 is 16. So if I doubled my side, I also doubled my perimeter. So, so the perimeter is doubled if you double your side. Our next problem. The relationship between the length of a side of an equilateral triangle and the perimeter of the triangle can also be graphed. So I'm going to draw an equilateral triangle, and you will notice it has how many sides? Good, it has 3 sides. So write an equation of the function using this s for the length of a side and p for the perimeter. Then complete the function table. So take a minute, pause the video, and go ahead and finish that on your own. All right, let's check your work. So you should have noticed that the perimeter is the same as 3 sides. We add up those sides, or we multiply times 3. And 1 times 3 is 3, 2 times 3 is 6, and 3 times 3 is 9. Now we just go and graph our points. So the first one, we have 1 and 3. So we're going to go over 1 and up 3 and put a dot right there. The next one is 2 and 6. So we're going to go over 2 and up 6. Put a dot right there. And our last one is 3 and 9. So we're going to go over 3 and up 9. And it's going to be about right there. Then you're going to take a straight edge and you're going to draw a line through your graph and hope that I can draw straight, or I figured out where to put those dots pretty well. And then I just make my dots so they hit that line really well, so it's obvious where they are. And can I go smaller than 0 with a side length? No, I can't. You're not going to have a negative something side length. But we can go bigger than 3, can't we? Yes, we can. We can go a lot bigger. So we're going to have array again for this one. Rates. So we talked about rates like miles per hour. Rates are functions that can also be graphed. Many rates involve time as one of the variables. Speed, for example, is a function of distance and time. So it says Sam enters a walkathon and walks at a steady rate of 3 miles per hour. This table shows how far Sam walks in 1, 2, and 3 hours. So he walks 3 miles in 1 hour, 6 miles in 2 hours, and 3 miles in 9 hours. A graph of the function shows how far Sam walks in any number of hours, including fractions of hours. Notice that each tick mark down here on the horizontal bar, where we have time in hours, they've actually split it into fourths. So you can break it down all the way down to a fourth of an hour, or otherwise known as 15 minutes. So here's another one, and this time they didn't break it down to fourths, they broke it down into fifths, six, and so if we break that down into 6, that's 10 minutes for each of those. So Sam entered a jogathon and was able to jog at a steady pace of 6 miles per hour for 2 hours. So he went a total of 2 hours, and he went 6 miles per hour for 2 hours. So we're going to write an equation for our 6 mile per hour rate and then complete the table. So I want you to take a minute, pause the video, and solve as much as you can. All right, so you should have noticed that he went 6 miles per hour, so our distance is 6 times h being our hours. And then you should have filled in your table. So 1 hour, he'll go 6 miles, and 2 hours is 2 times 6, which is 12 hours. And so we're going to graph that on our table over here. They've already graphed 1 hour, and we're going to graph 2 hours, which is about about right here. And so then you're going to go ahead and you're going to draw a line through that. We're going to go ahead and draw a line through that. And now you notice that he only went to a total of 2 hours. So we're going to draw a line segment starting at 0 hours. And we're going to go just to the 2 hours. And I keep losing my color, so I'm going to do it without And it's going to start at 0 because we had a 0 hours. Apologize for all this stuff coming up. I was trying to use straight edge and it wasn't working. Alright, so we end up having a graph that, oh, but I don't want an arrow because he didn't go any longer than 2 hours. He stopped at 2 hours. So this is going to be a line segment. So they want to know how far he jogged in 40 minutes. Well, 40 minutes is at about right here. So if we look over, whoops, on a straight line, we end up between 2 and 4. So we're going to say 3 miles. Then it says, refer to the graph to show how long it took Sam to jog 9 miles. Well, 9 miles is between 8 and 10. So we're going to draw a dot out to our little line. And we're going to go down to about here. And you should have ended up at about 1.5 hours. It says, why is the graph of the distance that Sam jogged a segment and not a ray? So, is Sam going to jog forever and ever and ever? No, that can't happen. So it can't be a ray because a ray means forever, right? But the story problem told us he jogged for 2 hours. So he's not going to jog forever, and he did stop after 2 hours. So a thing that you need to know that's really important, a vocabulary word or words together, is direct variation. Direct variation, because there's 2 different types of variation we're going to talk about. The first is direct variation. It's a relationship between 2 variables in which an increase in one results in a proportional increase in the other variable. So if it increases, it's going to increase. The other one's going to increase. And if one decreases, the other one's going to decrease proportionally. So it's going to proportionally means the same amount. So if it increases like 3, if one variable increases by 3, the other one's going to increase as well. So make sure that they both increase or they both decrease, and that means direct variation. So it says, for example, the longer you work, the more you get paid. The less you work, the less you get paid. The 2 pairs of numbers will follow the rules of the function. So for this one, for every hour that you work, you'll get paid $5 an hour. So 5 times 1 equals 5. 5 times 2 equals 10. 5 times 3 equals 15. And 5 times 4 equals 20. So it's always going to increase by the same amount every time you go up. The table above shows the number of dollars Gina earns working a given number of hours. Take 2 pairs of the numbers and use them to write a proportion. So they used 2 and 10 and 3 and 15. And we're going to see if they are equal. And the way we do that is by cross multiplying. And so 2 times 15 is 30. And 3 times 10 is 30. So the answer is yes. They are proportional because when we cross multiply, they equal each other. So on here, we're going to look for one that is not an example of direct variation. Remember, they both have to go up or increase, and they have to both go down or decrease. So the length of a side of a regular hexagon and the perimeter of a hexagon. So if we have the length of the side and it's 2, and we multiply that times 6, the perimeter is going to be 12. So 2 and 12. And if it's 3, we still are going to multiply times 6, and it's going to be 18. Did both those numbers go up? Did they increase? Yes, they both increased. If it's 4, it will be times 6, which is 24. Did that increase? Yes. So A is definitely direct variation. Do D for direct. All right. The number of books in a stack and the height of the stack. So books and height. So if I have one book, maybe the height is 2 inches. And if I have 2 books, the height will be 4 inches. And if I have 3 books, the height will be, 6 inches. Do both sides increase? We have 1, 2, 3 going up, 2, 4, 6 going up. So yes, they both increase. That one is direct variation. The next one says the speed at which you travel to school and the time it takes to get to school. So we have speed compared to time. So if you go 30 miles per hour and it takes you, we'll just say 30 minutes to make our life easy, 30 minutes to get to school. But if you go 60 miles per hour, it only takes 15 minutes to go to school. And if your mom or dad is a speed demon and they go 90 miles per hour, oh my goodness, how fast will they get to school? It'll be really fast. It'll take 7.5 minutes to get to school. Now notice your speed is going up, right? However, the time that it's taking to get there is going down. So this one goes up, the other side goes down. Are they both increasing? No, one increased and the other one decreased. This is not direct variation. This is not. Okay? Then the last one, the length of a segment in inches compared to the length of a segment in centimeters. And so 1 inch is like 2.54 centimeters. 2 inches is going to be 5.08 centimeters. Did this go up? 1 up to 2? Yes. And 2.54 up to 5.08? Yes. So that one also is direct variation. So the question again was, circle the letter, the one that is not an example of direct variation. The only one that is not an example is C. Now, one thing you need to know about graphs of direct variation, well, 2 things. Number 1, it's always a straight line. Always. Number 2, it always includes the origin. Always. Okay, so we have to look down here at A, B, C, and D, and I want you to tell me which one of these is an example of direct variation. Oh, I've got to give you one more rule. Number 3. Number 3 is it's going to go up to the right. So it's going to start from down on the left and it's going to go up to the right. So we got to circle the letter. Which one is an example of direct variation? Well, hopefully you knew right away it is not C, because look at that curvy line. And you knew it was not B because that line doesn't hit the origin. So it has to be A or D. And we have to think about that third rule, which it's interesting because they didn't tell us that in the book. The third rule says it has to go up from the left to the right. Only one of them starts at the left and goes up to the right, and that one is A. So A is our best answer. All right, let's look at another problem. The carousel at the fair makes 3 revolutions per minute and operates for 4 minutes at a time. So 3 revolutions, that means 3 times around. Revolution is around, okay? And it operates for 4 minutes at a time. Write an equation and complete the function table that relates the input, to, which is minutes, to the output, which is revolutions. Then plot the numbers on a coordinate plane and draw a segment for the length of a ride. So R is our minutes times 3. So if we go 1 minute, it's going to go around 3 times. If we go 2 minutes, it's going to be times 3. So 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. And then we're going to go ahead because it goes 4 minutes, right? And 3 times 4 is 12. Excellent. So take a minute, pause the video, and go ahead and graph this function. Great. So let's check your work. So the first one we have 1 and 3. So we're going to go over 1 and up to the 3. So we're going to go right here. The next one we have 2 and 6. So we're going to go over 2 and up 6. The next one we have 3 and 9. So we're going to go over 3 and up to the 9. And last but not least, we have 4 and 12, and we're going to go over to the 4 and up to the 12. Now we're going to draw a straight line through our dots. And keep in mind, it only ran for 4 minutes, so this is going to be a line segment. It's going to start at 0 minutes, and it's going to end revolutions, and it's going to keep going up, 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 and it's going to stop at 4 minutes, because remember, it only goes 4 minutes at a time. Alright, so the other type of variation, that was direct variation. This one is inverse variation. Inverse variation is a relationship between two variables in which an increase in one variable results in a proportional decrease in the other variable. Remember when we talked about the time it would take to get to school? The speed increased, but the minutes it took to go to school or get to school decreased. All right, so Adam is taking a 120-mile trip. The faster he drives, the shorter the time it takes to get there. The variables in the speed or rate and the time. The variables are the speed or rate and the time. The distance does not change, okay? No matter what, he's taking a 120-mile trip. In an inverse equation, the variables are multiplied and the product is constant. So you're going to multiply your variables, your rate and your time, and your distance is going to stay the same. So our distance is going to stay 120 the whole time. So they're saying if you go 60 times 2, it's going to get you there at 120. It's going to get you to your 120 miles. So if you're going 60 miles per hour for 2 hours, you get there in 120 hours. So T equals, in number 12, we're going to do T times 40. So we have to figure out what 120 equals 40T. What can you do to solve that? We got to get our variable, isolate our variable. So good, we're going to divide both sides by 40, and we're going to find out that T equals 3 hours. And you're going to write it right here. And we're going to finish up our table. So we have to think 30 times what number equals 120. Go ahead and finish the table. Excellent. So I'm going to make sure you can check your work. I know that 30 times 4 equals 120, and 20 times 6 equals 120. So that finishes my function table for this trip. So you probably noticed when we multiplied them, all of them equaled 120. They're all equal. So the products are equal. So now we're going to graph our pairs of numbers in the table. Notice the points are not aligned and that 0, 0 is not a solution pair for this function. So we're not going to put the origin in this one. Okay, so I'm just going to take a minute, take a quick screenshot. And all right, so now we have the screenshot of what we did, and we're going to graph it. So if our time is 2, our rate is going to be 60. So about right there. If our time is 3, our rate is going to be 40. Go ahead and take a minute and finish your table. Pause the video. Excellent. All right, let's check your work. So if the rate or the time is 4, our rate is going to be 30. And if our time is 6, our rate is going to be 20. And you'll notice there's a curve in our graph, okay? So make sure that you have that curve. And we're going to draw our line through the curve. And you'll notice that if it's an an inverse function, it's going to be a curved line. We have a curve. So here's some information that you need to know. The graph of an inverse proportion is a curve and not a line. The graph does not include the origin. It does not intercept an axis. It can even include points in the third quadrant. So it can have points in any of the quadrants. Work problems are also functions that involve multiplying variables. Work problems talk about person hours or person days. A person hour is one person working 1 hour. Projects need a certain number of person hours of labor to be complete. This is the constant in the equation. We multiply the number of people working times the number of hours they work. If more people work, it will take less time. So, according to this, it will take 48 person hours to roof the whole house. It will take 2 people 24 hours to roof the whole house. With 3 people working, the job still takes the same amount of work. It still is going to take 48 person hours, but it's going to take less time because you have 3 people working. Okay, so 2 people times 24 hours is going to be 48 hours. And we can do that 48 hours with 3 people instead, and they want to know how many hours those people are going to have to, each of those people is going to have to work. And so we're going to isolate our variable again by dividing by 3. And so we have to figure out what 48 divided by 3 is. Take a minute, pause your video. Good, so let's check your work. Good, so you should have told me that 16 hours equals T. So if 3 people work, it's going to be 16 hours. So here's another problem. If 3 people can harvest the field in 8 days, how many people are needed to harvest the field in 2 days? So 3 people are going to take 8 days. So that's 3 times 8, which is 24. So we need 24 person hours. And they want to know how long it's going to take, or how many people they need if they only want to take 2 days. So 2 days. So we're going to divide. We're going to get our, isolate our variable by dividing by 2. And so you're going to end up with 12 people. 12 people. If you want to do it in 2 days, you need 12 people to do it. Says we can also use inverse variation to help us multiply numbers mentally. If we need to find the product of 2 numbers, we can decrease one factor and increase the other factor proportionally. So if we take half of 24, or say we want to multiply 24 times 15, if we take half of 24, which is 12, and we double the 15, so we divide 24 by 2 and we multiply 15 by 2, we can find our answer mentally. 12 times 3 is 36, and put your 0 at the end. We end up with 360. Pause the video and try number 18. All right, so we can double the 25, which is going to give us 50, and we could take half of 18, which is 9. 5 times 9 is 45. Put your 0 at the end, so the product is 450. All right, so here's some characteristics of inverse variation that you need to know. As one variable changes, the other variable changes inversely, so it's the opposite. 0 is not a solution for either variable of the function. It's not going to go through the origin, never. And last but not least, the products of the number pairs that satisfy the function are equal to each other. So all of them are going to be equal, just like I showed on that function with the 120 minutes. All right, or 120 miles. All right, have a great day. I hope this helped you.